Hello. Very pleased to be here again. This is the fifth of these 6 Royal Institution Christmas lectures on the planets. And today we are concluding our discussion about Mars with a discussion of the Viking missions to Mars, which are the most definitive exploration of another planet that has been performed to date, and which involves not only the first close-up looks at the surface of Mars, but the first serious search for life on the surface of another planet. The Viking spacecraft is shown here. This is a model of it. It is a orbiter-lander combination. When it is launched into space, these great solar panels unfold to convert sunlight into electricity and power the spacecraft on its year-long journey to Mars. There are rockets attached to make mid-course corrections of the trajectory. The orbiter has attached to it a lander, which is wrapped up in this cocoon, and it emerges from the cocoon only when it enters the Martian atmosphere. Before it does that, it must check out landing sites on Mars. And so the entire orbiter-lander combination goes into orbit about Mars and might be there for weeks or months until a correct, proper, safe landing place is chosen. Then the lander descends to the Martian atmosphere, lands, we hope safely, on the surface, and the orbiter continues to do its work. Well, that happened. The spacecraft were launched, 2 of them, 2 orbiter-lander combinations, in the summer of 1975 and arrived at Mars in the summer of 1976. We can see the launch of the spacecraft here, and it's taking off from Cape Canaveral in Florida, and the spacecraft itself is at the very tip of this very large Titan Centaur launch vehicle. We can see the kind of pictures that Viking obtained. This is a picture acquired before Viking 1 went into orbit around Mars. And among the many features of great interest seen is a great rift valley right here, which is 5,000 kilometers long, about 3,000 miles long, and is an enormous feature, very young by geological standards, and is a sign that Mars is geologically active today. We can also see big frost-filled craters, basins, and many other regions of interest. Another picture taken later in the mission, but of the same sort, is this lovely picture of a crescent Mars, and in the upper corner here is a picture of a great volcano with clouds trailing off the summit. And down at the bottom here is a patch of frost that's visible with a great impact crater in its center. Here is a close-up of a very small region, only about 50, 60 kilometers wide, of the Great Rift Valley, which is this feature right here. And you can see that there have been great avalanches which have collapsed from the walls and slumped down into the valley. This is a scene of enormous geological activity. Here is a close-up of a mosaic of 3 pictures, one at right, one at center, one at left, which are neatly pasted together. And you can see that the Great Rift Valley, which is here on Mars, has eaten away into this pre-existing impact crater here. And as the Rift Valley continues to have its walls slump, it will eat into the features at its edge. You can also see the marvelous cracks in the floor of the crater, which have been produced by this slumping. Here is a close-up of a different region in the floor of this enormous valley, and it is covered with sand dunes, and as the cameras do a nice close-up, we can see a very large number of sand dunes stretching for many tens of kilometers across the bottom of the floor of this great valley. Here is a picture taken obliquely, not looking straight down, but looking off towards the edge of the planet. And again, you can see it's a mosaic made of several independent pictures put together. And the first thing we see is a great basin. This one is called Argyre. And it is obscured because there is dust in its atmosphere and dust in its surface. And the detail, the geological detail that's there, is difficult to see as a result. Argyre and other great basins, the biggest one is called Hellas, which is Greek for Greece, are the sources of the dust for some of the great dust storms. You can see at the periphery of Argyre, the ground is very detailed and chopped up, not obscured at all, as in the interior. As we look towards the edge or limb of the planet, we can see the Martian horizon, and also we can see a detached cloud or limb haze. There are clouds of condensed carbon dioxide, of condensed water, like here, and there are also often dust clouds on Mars as well. Here is a close-up of a Martian crater of a sort that we never find on, say, the Moon or on Mercury. The crater itself looks ordinary enough, and it has a central mountain peak, as many lunar or Mercurian craters do. But on the periphery, there is what is called a lobate ejecta blanket. It's a big, long set of words. Lobate means it looks like it has lobes on it. Ejecta means it's been thrown out from the crater. And blanket means it's lying on the surface. Instead of having an irregular pattern, the material which was thrown out by the impact has this form of lobes, fingers. Now, what could that be due to? It is due, we think, to the fact that the Martian surface material is composed of permafrost, ground soil mixed with ice. As the impacting object comes in and makes the hole, it also melts some of the ice. The ice then provides a lubricant, a medium on which the sand and dust can spread outwards, and that continues to flow out in this form until the water freezes again, and then the lobate pattern stops. So this is indicative of the frozen water content of the Martian subsurface, which we know about on other grounds already. Now here is a picture which reminds us that Viking, as well as Mariner 9, has found sinuous valleys, the remains, we think, of ancient rivers, but this particular one is filled with fog. There is local weather on Mars, and a picture taken a little bit later showed no such fog. There's an early morning fog in a lowland valley on Mars. And here we see a remarkable set of features, generally boxed in valleys of very large proportions, many tens of kilometers long. And perhaps you can see a set of striations which run the length of the valleys. That's a very nice close-up, which follow the contours of the valleys. Now, on the Earth, there are some features like this which are produced by glaciers, but to the best of my knowledge, none on this scale. If this is produced by glaciers, it indicates a time when there were glaciers of very major proportions on Mars, and this reminds us of something we talked about in the last lecture, that there might be major climatic change on Mars. Here is a Viking 1 photograph of the polar caps. Here to top right is high ground. Here to bottom left is low ground. And here is the transition, almost vertical cliff face, which is about 2 kilometers high. And there are these tongues of ice hanging down the sheer cliff face. And you can imagine that would be quite an interesting place to be in. And up here to the right might be a nice place to ski on. I don't think anyone will do that in the near future, however. Well, these are some of the pictures that we looked at before landing on Mars. And when I say we looked at it, many, many scientists involved. And here is a picture of a group of them looking in stunned amazement at some of the first pictures. And I show it to you to indicate this is not uniquely an American enterprise. This gentleman is C.B. Farmer, and this gentleman is Michael Carr, both of whom are British citizens. I picked it out just to show the British audience that it is possible to be British and to be in planetary astronomy at the same time, although there's not much evidence of that in the United Kingdom at the present moment. Now, the question of landing on Mars is a difficult one. We had never landed on Mars before. And there are things about Mars which we might consider dangerous. There were very peculiar radar reflection characteristics from Mars. A radar telescope on the Earth gave an indication of extremely soft ground on Mars. There are other places where we thought the ground was extremely rough. And the spacecraft coming down was very vulnerable to rough or soft ground or many other criteria. The spacecraft is a few meters wide and 1 or 2 meters high. A rock of a meter size could make the thing land at a peculiar angle, roll over, and die. If the ground was very soft, the spacecraft might sink into the ground, say up to its eyebrows, and be unable to see anything on Mars, and that would be unpleasant. So we had to choose safe places. But since no one had ever landed on Mars, that wasn't so easy. What is more, the orbital photography of the sort I've just showed you had a resolution, an ability to see fine detail, which was at best only about 100 meters. Anything smaller than 100 meters we couldn't see. But a rock a meter across could destroy us. So we had to somehow guess from what we see at 100-meter resolution to what might be on the ground at 1-meter resolution. And you can't do that unless you really understand the terrain. So the idea was to find places on Mars which were fabulously dull, in which there was nothing whatever of interest to be seen. That's the place to land. Now you can see that that lets out all of the exciting places we just looked at. You can't land in a river valley, you can't land on the slope of a volcano, you can't land in the polar ice. You can't land in any of those nice, interesting places. You have to land in the dullest, least interesting place you can find and hope that you could survive there. Now, an indication that we had to take this very seriously came from the fact that there had been at least 3 dramatic Soviet failures previously in trying to land on Mars. And one of those failures is indicated in this postage stamp, which shows the Mars 3 spacecraft entering through a kind of purple muck. You can see purple muck up here on the right. The artist who drew this postage stamp quite correctly was indicating that the Mars 3 spacecraft had entered in the midst of a great sandstorm. The Soviet spacecraft had been pre-programmed so that where and when they landed on Mars was determined at the time of launch. And the fact that there was a great dust storm on Mars came in too late to change the protocol. And what seems to have happened for Mars 3 is that it came into the Martian atmosphere, had a big billowing parachute which slowed it down nicely, and it touched down at the Martian surface with a speed in this direction which was very gentle. Unfortunately, the big parachute very likely picked up the enormous winds that were driving the dust storm going this way, and so the spacecraft landed gently, vertically, in the horizontal direction. It was going extremely fast, and perhaps hit some obstacle, fell over, lost radio communication with the flyby spacecraft, which was its link to the Earth, and failed within 20 seconds of landing. The latest Soviet spacecraft failed mysteriously within 1 second of landing. So as a result of all this, we wanted to be extremely cautious. Now, a picture of where we hoped to land is shown here. This is a region called Chryse, C-H-R-Y-S-E, which is Greek for the land of gold. And scientifically, it is a land of gold because you can see all the signs of past running water that are through this region, which is shown in this lovely mosaic. Now, we see an ellipse, which indicates how confident the navigation team was about where they could land. They said that there was a 99% chance that they could land within that outer ellipse. But when we looked closely at that terrain, it looked dangerous. At least it didn't look familiar. We weren't sure about it. And so we had to move. And here we have a picture of first where we originally started out, then where we hoped to get to next, and finally where we eventually settled on. And that took quite a while. And in that period of time, while we were trying to figure out a safe place to land, July 4th, 1976 came and went. That was the bicentenary of the United States. It would have been nice to have landed on that date, but we thought it better to miss that date than to crash on that date. That seemed to us not to be a marvelous birthday present for the United States. So we, in fact, did not land until July 20th, 1976. And we can take a look at a close-up of this fabulously dull region. You can see that it has nothing whatever of interest on it. It has a few impact craters. It has a kind of real soft, muted terrain of the sort we know from on the moon. Well, there is this cross. If the cross was on Mars, this would be a place of some interest, of course. But this is put on by the artist to indicate where we hoped to land. In fact, Viking 1 successfully landed within about 30 kilometers of the designated landing place after an interplanetary voyage of over 200 million kilometers, which lasted more than a year. Precision targeting. The landing sequence went something like this. Here is the orbiter, which is separating from the lander, wrapped up in its aeroshell. The lander then slowly enters the Martian atmosphere, still in orbit, but spiraling in, slowed down by the Martian atmosphere. Then once in the Martian atmosphere, the lander, still in its aeroshell, is connected to the parachute, which is just unfurling or deploying. It opens up, very large, 55 feet in diameter. That slows it down still further. And then finally, the retro rockets fire, which you can see here, and the spacecraft gently, we hoped, settles down on the Martian surface. Now, before I discuss what we found, I want to do several things. One is I want to show you a little bit about the Viking lander, and then I want to describe how the Viking cameras work, because that's essential if we're to understand the pictures that we will see. So here is a model, thank you, Bill, of the Viking lander. And we can see a number of things. First of all, there are foot pads, 3 of them. It's a 3-legged beast, and it lands on those 3 foot pads. Unfortunately, it cannot move the feet, so we cannot take a walk, and that's a point I will come back to towards the end. It talks to the Earth 2 ways. With this large radio telescope, it talks directly to the Earth when the Earth is in the sky. That is not always the case. More often, it talks to the orbiter when the orbiter is overhead with this smaller radio telescope right here. It has a computer which gives it a great deal of information about what to do, and that computer can be instructed from the Earth so it can learn new things. As I mentioned before, it has retro rockets so that it can brake as it lands, but they're turned off before it's over the landing place so it doesn't fry the ground it's to investigate. It does not work by electricity generated from sunlight. Instead, it works by electricity generated by nuclear power. And there are two nuclear power plants here and here, which give energy even at night when the sun, of course, is out. There is a sample arm which can reach out about 3 meters long, acquire a sample of Martian surface material, withdraw it back into the spacecraft, and it then looks at that sample with 5 different experiments, 1 on inorganic chemistry, 1 on organic chemistry, and 3 on microbiology. And we'll talk about those experiments later. There is a meteorology boom which gives almost hourly weather reports about Mars. And finally, there are these 2 turrets which are cameras. And those cameras work in a way different from the ordinary sort of camera. And I'd like to say a little bit about how they do work. Essentially, there is a nodding mirror inside which bobs up and down and measures a single line of information in the scene. So if I were looking right here, I'd see, because this young man is wearing a dark suit, a dark jacket, dark sweater, I would see dark, 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 dark. Then I get to his face, which by accident happens to be lighter, and it would be lighter. Then the person behind him would be dark, light, dark, light, dark, light, dark, light, and so on. And I'd get, in this single line, fluctuating darkness and lightness. Then the turret would move a little bit, and I would do another line. And in this way, I would slowly build up, line by line, an impression of what the scene is. Now, over here, we have made a kind of duplication of the basic idea of the Viking camera. So here is a nodding mirror, and you can see it has an ability to nod up and down and build up some information on the scene. Now, the light comes in, is reflected off the mirror, goes through some optics, goes to a photocell, which converts that amount of light to electricity. Then the electricity is measured on a device here called an ammeter, which just measures the amount of current that flows through. Now, what we're going to do is have a volunteer. I haven't said what you're volunteering for yet. How do you know you want to do it? Maybe it'll be terrible. Let me say what the volunteer is going to do, and then you can see if you really want to do it. Actually, it's very interesting to do. The volunteer is going to stand over here where he can't see what's happening over here. And we're going to pile up some blocks in a certain pattern of white, gray, and black. The volunteer is going to stand over here and look at this ammeter, and when there's a lot of current, meaning it's white, he'll put a white block there, and when there's only less, we'll put gray, and when there's even less, we'll put black. And we'll see the volunteer building the blocks up here. There'll be a pattern over here, and at the end we'll see if the same sequence of bright and dark is built up on both sides of this barrier. Now, who would like to do this? Okay, let's see. Can I have you, please? I'd like you to stand right here. Let's put these blocks down here. You'll use these. We're going to start with a white block just so we'll check out that everything is right. And what you have to do is look at this meter. And when it's all the way over here, it will signal white. When it's over there, it'll signal gray. When it signals over here, it's black. And I'll tell you when I'm going to each additional block, okay? Now, the one thing you have to promise not to do is look at the television cameras, which will tell you what's happening on the other side. Okay? Just step over there. Good. Can you see the ammeter still?
Yes.
Is that okay? Okay. So now I'm going to go over here and try not to be in the light. And I will change the mirror, I'll nod the mirror by turning this screw. And now, just to check that we are on the white block, I'm going to put my hand over the block a little bit and notice that the needle does change. Okay, so now, are you ready? Okay, so now I'm going to turn the screw and I'll tell you when I've gotten to the next block. I have now gotten to the next block, put some appropriate colored block on. Have you done that? Okay. Now, next block is now. Would you put that block on, please? Have you done that? Okay. Now, the next block is here. Have you done that? Whoa. Have you done that? Good. And now the next block is here. Have you done that? Okay, so we have 5 blocks here, 5 blocks on the other side. Let me pull this partition away and let's see if we have the same sequence of 5 blocks. White, black, white, gray, white. White. Thank you very much. That was really very good. Well, now, you see you could build up the image of anything. You could build up not just the images of blocks, but of elephants or armadillos or whatever happened to be around. So now I'm going to show you a sequence in which Viking lands not on Mars, but in a different kind of Mars. This videotape shows a Viking lander as if it were to land on an exotic other world called Earth in a place called Mars, Pennsylvania. In the United States, we can see here the Mars drugstore, and there is the Viking lander sitting on the main street of Mars, Pennsylvania. And now, if only there was some sign of life there's the Viking camera, and now if only there was some sign of life to detect, who knows, maybe the Viking cameras might be able to detect the life in Mars, Pennsylvania. My goodness, what's this? There's Viking taking it all in. Now, here is a picture below taken by an ordinary camera, and above we will see line by line the Viking image build up. And the interesting thing is, while the background it sees fine, anything that moves it can't see so well, and so it's going to miss a lot of the moving objects, whatever they are. Now, that's the situation on Mars, Pennsylvania, and the question is whether the situation on Mars is different. Here is, in fact, the complete build-up of the picture on Mars, Pennsylvania, by the Viking lander seen above. And you can see all of the invisible dominant organisms marching by, but which Viking could not see because of its nodding camera mode. Now, with this introduction, let us see what is on Mars. If there is life on Mars, the one thing we can be sure about is that it will not look like the life in Mars, Pennsylvania. Whatever else might be there, we have no way to know. Viking was the first attempt to look close up at the Martian surface, and let us now spend a little time examining what Viking found. Here is a portion of the first photograph ever returned from Mars. A portion of the Viking footpad can be seen to the right here. You can see it sitting high above the Martian surface. It did not sink in. And here, adjacent to it, is the first look at Mars we ever saw. And you can see it has flat rocks and clods of dirt and looks like your grandmother's garden. If we look at another footpad, here's the footpad. Here's the support of the footpad. The footpad itself is buried in Martian soil. So Viking 1 landed in a place which was hard on one side, soft, so soft on the other that it slipped into the ground. And if we were to look out towards the horizon, we would see why this is the case. This beautiful picture is bisected by the meteorology boom, you see here, and there's some other Viking spacecraft parts in the foreground, and behind it is Mars. And you can see a large boulder, you can see other rocks, and you can see lovely sand dunes behind. It looks like many places on the Earth. The governor of Nevada once told me that he knew a place in Nevada that looked exactly like this. And you can almost imagine a sort of grizzled prospector pulling his mule along, coming out from behind one of those sand dunes. But no grizzled prospector was found. Here is a close-up of these sand dunes, and it's quite amazing how similar they are to the sand dunes on the Earth, say in the Sahara or the Mojave deserts, despite the fact that the particle sizes, the wind velocity, the atmospheric pressure are all extremely different on Mars. There's a great deal to learn about deserts from studying Mars. And now here is another color photograph, again bisected by the meteorology boom. You can see now color photographs of the sand dunes towards the horizon. And now here is quite a pretty picture showing in a different direction, away from the sand dunes, the field of rocks and boulders. Notice how the boulders in middle distance are dark colored, quite different from the boulders in foreground. If we look now at the next photograph of Mars, we see a close-up of a rock to the right, which we originally called Big Bertha, but there was a complaint from a women's liberation group, quite properly we thought, and so it is now called Big Joe, and no one has complained. Big Joe is so large that had we landed on it, we would have been destroyed. Viking 1 would have been destroyed. And is an indication that it is not terribly easy to land on Mars. Now here is a field of strewn rocks lying before the spacecraft. You can see it's very hard, rocky ground. But if we take a close-up look in this scene, we see that behind many of these rocks are tails of sand, raised, elongated streaks of sand, all pointing in the same direction. And this is very similar to the situation we talked about in the last lecture, in which there were such streaks behind craters. And the situation is just the same. In fact, we found that the direction that all of these streaks point is the same as the direction that big streaks point in this same region. These are wind markers from the last great dust storm in this region. And they point in the direction that the wind blew. Now, things do change on Mars. Here is a photograph of Big Joe, and here's Big Joe, and here is a small rock, and you can see that between this small rock and Big Joe there is no rock. But now, if we dissolve to a picture taken just a little bit later, we see that suddenly there has appeared another rock in an intermediate position, and that rock, here we are going back to the original, and now we dissolve to what it looked like later. Now, that is a change which has occurred in a small scale in a short period of time on Mars. Either the wind has uncovered that rock, or the sand has slid off the rock because of a small Mars quake or something of that sort. There are Mars quakes. One was detected by the seismometer on Viking 2. Now, we put on top of the Viking lander a kind of grid, which you can see here, a kind of checkerboard, to show the positions of things we dumped there. And then we had the sample arm reach out, acquire some Martian surface material, and like an elephant washing itself with sand, dump the sand on its back. And here is what that looked like. Here you can see the same grid now all discolored with the sand. And we watched this, and as time went on, the sand moved, gradually blowing in this direction and in this direction, gradually accumulating against this device. Now, This is the first close-up investigation of the motion of fine particles on another world. And we have found that not only does this occur, but we have found what wind velocities are necessary when it does occur, and very high winds are required, as we had suspected long before. Now, all of this discussion so far has been about the Viking 1 lander, and I'd like to talk just a little bit about Viking 2. Here again, we wanted to land in a safe place, and we were running out of time because in November of 1976, Mars was passing from the Earth's vantage point behind the Sun, and we were not sure that we would be able to reacquire the Viking landers after that solar occultation event. So we wanted to put Viking 2 down on Mars and get some preliminary information before November. On the other hand, once we had Viking 2 in orbit about Mars and looked at the region we were in, we found some extremely strange terrain which we did not understand, and again we were worried that we would crash the spacecraft as we landed. So, for example, one strange place that we saw was this region, which you can see here in the lower left seems to be covered with giant fingerprints. You see all these ridges that are in parallel and curved. The ridges are about 1 kilometer across, so it's an extremely large fingerprint. And since there are craters on top of the fingerprints, this one, for example, these are extremely old fingerprints. They are, of course, not fingerprints, but what they are, we don't know. And if we don't know, we must not land there. So we moved on to a different longitude in the same latitude, and we came upon ground like this, in which there are roughly polygonal patterns covering the landscape for tens and hundreds of kilometers. Such things are known in the small, in the Arctic regions of the Earth, but never at this scale. Again, we had to be extremely cautious and not land here. Eventually, we found a place which looked sort of all right. There wasn't anything too bad, or at least too puzzling near it. We sat down and landed successfully, but we were lucky. Here is the first photograph from the Viking 2 site. The Viking 2 landing place was called by the old astronomers Utopia. So in case you've wondered what Utopia looks like, this is it. Here is the lander footpad. You can see it's covered with Martian surface material, which was obviously thrown up in a great cloud as we landed. Here is a rock which we think we turned over in the process of landing. We did land on a rock, and in fact we were tilted 7 degrees for the rest of the mission. And here is a rock which is vesicular. It's full of holes. And whether that's because of sand blown by wind eating out the surface material, or whether this is a kind of rock produced by volcanic events, we don't know. But it is a kind of rock we never saw in Viking 1. Now, when we step back and look towards the horizon, again, that's the meteorology boom you've seen before off to the left. There are, you may think, strong similarities between this scene and the Viking 1 scene. That's certainly right in that there are rocks extending out to the horizon. There are also a number of differences. One of those differences is the existence of this trench or furrow, which you can see runs straight across the picture. And in fact, when we map all of those furrows in all directions around us, they seem to also make a kind of polygonal pattern. We seem to be on patterned ground, and perhaps that is due to permafrost, as in the terrestrial Arctic, but perhaps not. There are also no sand dunes in this region. That's another difference. If we take a close-up look at the trench, here it is up here, we can see in it a pyramidal-shaped rock, and whoops, there it is, pyramidal-shaped rock, and also a sheer face of a rock that seems to have recently been cut by what, we are not sure. Well, this is an extremely quick look at the Viking 2 landing place. In fact, both Viking landers are still all right, and both Viking orbiters are sending information back. We have acquired an enormous amount of information about Mars, and I've touched only on a tiny amount of it. But the question which everyone likes to ask, and which Viking was in fact intended in part to try to answer, is the question of life on Mars. Did we find any life on Mars? Now, there were many speculations which we've talked about. For example, Percival Lowell's idea of great canals. Notice we did not see anything like a canal in any of these pictures. Then there are views of other people. For example, this artist's conception of what we might find. Certainly be extremely interesting if we found exotic life forms such as this animal in left foreground and strange cabbage-shaped Martian plants in background. We saw not a hint of anything like that. Here is another possibility that someone proposed. A creature not just large enough to see, but interested in us, in the Viking lander, and in this particular case looking straight at the cameras, we certainly would have gotten a lovely close-up of its eyeballs if there had been such a creature, but we saw nothing like it. Nor did we see any artifact, any sign of manufacture of intelligent Martians. Here is, in fact, an artifact right here in the center foreground, but it is not an artifact from Mars. It is a product manufactured on the planet Earth. It is, in fact, the glove that covered the sample arm before the sample arm was deployed or used. And nothing of Martian manufacture was found, not even a wrapper to a stick of chewing gum or anything like that. No hint of anything large enough to see that was alive. Now, what's the significance of that? Does it mean that life does not exist on Mars? It's certainly relevant to the question of life on Mars. Well, we landed only at 2 places on Mars chosen for their dullness. We cannot tell whether this is a typical place on Mars as far as biology, or whether it would be like landing in the midst of the Gobi Desert or the Antarctic ice cap, looking around, seeing no life, and saying, aha, the planet is uninhabited. For safety reasons, we had to go where it was dull. But if this is typical, if there are no large organisms on Mars, it hardly excludes the presence of small organisms, because the Earth, for example, had organisms big enough to see only for the last 500 or so million years. And yet there's been life on Earth for about 4,000 million years. For that period of time, the Earth was covered with microbes, but had no macrobes, no organisms big enough to see. So the negative results, which are very interesting and important, no organisms big enough to see on Mars, does not say anything about little microscopic organisms. Fortunately, Viking was designed to look for them also. The experiments are in some sense limited. They can only answer some questions, but they are a first attempt to approach this question. Now, the way these experiments work is that the sample arm goes into the Martian surface under guidance from the Earth and examined by television cameras. Here is a sample arm. I'm holding it, but in the real case, it's the Viking lander which holds it, positions it, and then gives the go-ahead, and we dig up some Martian soil, and it is withdrawn back into the spacecraft, and they're sent through a variety of hoppers and sent to the 5 experiments, 3 microbiology and 2 chemistry, and leaving behind a kind of small trench or furrow in the Martian surface. Such trenches or furrows can be seen. If we look at the next picture, we can see here to the right a picture of the furrow, and off to the left we can see the Viking sample arm that has dug the hole. We are playing in the sand of another world. And here is a sequence at left where we see the sample arm touching the Martian surface, moving a rock away, because we were interested in looking underneath rocks, places which were not exposed to the ultraviolet sunlight on Mars. And then off to the right, we see the moved rock and the furrow adjacent to it, which was made when we grabbed the sample and withdrew it back into the spacecraft. Now, over here, I am going to try to describe two of the experiments designed to look for Martian microbes, little organisms, if they exist on Mars. We don't know if they could exist. You remember we talked about some experiments with Mars jars showing that terrestrial little bugs might be able to survive and grow on Mars. We talked about experiments on the origin of life, in which the most common conditions early in the history of a planet seem to point towards the origin of life. Well, did that happen on Mars? Did life once originate on Mars? Did it evolve? Has it survived the changing climate of Mars? Could those microbes be in existence today? Well, I want to describe here, this is symbolic experiments. These are not the real experiments on Mars. We didn't have little eyedroppers and somebody to squeeze the eyedropper. But this indicates the basic point of these experiments. One experiment looked for the breathing, the respiration of Martian organisms. The idea was we brought to Mars food which we hoped the little Martians would love to eat, if there were any little Martians. Here, beneath this eyedropper, in this pipette, is some of that food. Below it is, imagine, Martian surface material which has been put there by the Viking sample arm. The food is radioactive. The Martian atmosphere is not radioactive. We drop the food onto the Martian surface. Now, if there are Martian microbes that love this food, they might oxidize it, as we do when we eat food, and give off carbon dioxide. That carbon dioxide would be radioactive. So if we found an increasing amount of radioactive carbon dioxide in the Martian atmosphere after giving food to the soil, we might deduce that there are microbes there. And so, in this experiment, we will want to put the active end of a Geiger counter into the atmosphere in here, and the increase in the rate of counting radioactivity indicates that there is radioactive carbon dioxide, only a little bit, but more than before, and therefore that some interesting chemistry, like respiration, has happened inside the chamber. There are always a few clicks, even when it's not close to radioactivity, because of cosmic rays coming in and striking the detector. Now, that's the story of this experiment. Here's, in a way, the opposite experiment. Here, the plants, I'll talk about in a second. We didn't have plants on Mars. They're just to help us understand. Here, we introduce radioactive carbon dioxide, C14 labeled carbon dioxide it's called, and see whether the Martian soil is able to capture, acquire, grab that carbon dioxide and convert it into organic matter. So here I am symbolically making carbon dioxide. Well, actually, I am making carbon dioxide by dropping sulfuric acid on some carbonate, and the frothing and bubbling that's going on there is the generation of carbon dioxide. Imagine now the radioactive carbon dioxide spreading out in the interior of this chamber, and the Martian soil acquiring that radioactive carbon dioxide, converting it to organic matter. That organic matter will be labeled with radioactivity. And so, if I can ask you to hold this without burning yourself with sulfuric acid, and take the Geiger counter. In this case, I'm going to put it on the leaf. And we see, sure enough, radioactivity has gotten into the leaf. That would prove, if this were on Mars, that the leaf was alive. Well, we know leaves are alive anyway. But if I put it down here on the soil, and imagine no plant there, then that would indicate that the radioactive carbon dioxide had been fixed, reduced, converted to organic carbon in the sample chamber. Now, the results of these two experiments are as I just described. Thank you, Bill. These two experiments gave, by criteria established before launch, positive results. If these two experiments had been landed in Piccadilly Circus and gave these results, you would deduce that there was a low form of life in Piccadilly Circus. Higher forms of life would be an open question, but low forms would be very, very likely. Now, that being the case, why don't we hear about lots of life on Mars? There are two reasons. One is that scientists are naturally cautious and think that it's better to make the mistake of saying that they didn't find life, even though later it turns out there's life there, than make the mistake of announcing there's life on Mars and later on find out it's a mistake. It'd be very embarrassing. The other reason is that Mars is not like the Earth, and there's a different kind of inorganic chemistry that can happen on Mars and not on the Earth. For example, ultraviolet light from the sun strikes the surface of Mars. That doesn't happen on the Earth because we have ozone here that absorbs the UV. Does not happen on Mars. So the UV, or ultraviolet light, strikes the Martian surface and changes its chemistry. It breaks down water, which is part of the molecular structure of the Martian soil, and oxidizes the environment, makes very oxidizing molecules like peroxides and superoxides. Well, if the Martian soil is filled with those guys, those kind of molecules, then it might very well break up radioactive food sent from Earth, release carbon dioxide, which is also radioactive, and fool us into thinking that there's life on Mars that's breathing and eating instead of just the chemistry of the soil. So that's a reason why it's most important to be cautious. But the actual situation is that nobody has gone into the laboratory and duplicated these experimental results from Mars. Nobody has, with inorganic chemistry, without life, been able to reproduce, simulate, duplicate these experiments. And until they have, the possibility is very real, in my opinion, that they are due to microbial life on Mars. The alternative explanation is that there's a funny chemistry on Mars which likes to do a chemistry which looks like respiration and looks like photosynthesis. If that's the case, that same funny chemistry probably existed in the early history of the Earth, because before plants, there was no oxygen, there was no ozone, ultraviolet light struck the surface of our planet. If that's the case, then we can understand much better how the early steps in the chemical history of life, the origin of photosynthesis, the origin of respiration, came about. Either way, I believe, these important Viking results have a profound implication for the question of the origin of life and its distribution through the solar system. The trouble is, we don't yet know which of these two different explanations is the right answer. And that is another reason to go back to Mars to look more closely. Now, to say just a few last words about the Viking mission, I'd like to show this rather recent picture. It's just a couple of months old, in which we can see all sorts of the parts of the Viking spacecraft in foreground. And in background, we can see a number of rocks. But notice that before many of the rocks, there is a kind of white patch. And that white patch is snow. It has been snowing. There has been frost on Mars. It's the winter season, and the frost comes in the nighttime, dissipates in the morning, and we are seeing signs of the weather on Mars. A second point which I'd like to point out to you is this object right here, which looks a little bit like a 35 millimeter slide or a some kind of square thing. It is not a 35 millimeter photograph slide. It is a microdot. On that little thing is written extremely small the signatures of 10,000 human beings who worked on the design, fabrication, testing, launch mission operations and scientific analysis for the Viking mission. There are 2 places on Mars, some thousands of kilometers apart, in which 10,000 people have their signatures. And that is, at least in a symbolic sense, an indication that we are becoming a 2-planet species. And the last picture I wish to show, it's common to end travelogues with pictures of sunsets. And here is a lovely sunset on Mars taken by the Viking 1 camera. But it is a sunset in a place chosen for its dullness. In fact, we know that it is about the least interesting place on the planet that we can find. We would like to go back to Mars and go to more interesting places. I myself would love to go to Mars. And I would love to take some people with me. I would like to take 2 people with me. Who would like to come to Mars? I am delighted that so many people wish to come to Mars. It's very good to come to Mars. Could I ask you to be very careful coming up? And could I ask you, please be careful coming up. And now I'd like you to sit on a Martian rock, if you wouldn't mind. Could you sit on that rock? Good. And could you sit on this rock? Thank you. Whoops, careful. Lightweight Martian rock. And I will sit here. And notice how noisy it is on Mars. We've never sent a microphone to Mars to hear what it's like there. For all we know, it's fabulously interesting. The wind is blowing and all of that. And maybe the rocks are creaky, like this. Maybe you noticed in some of the pictures that the sky was not blue on Mars, but pink. It's true, Mars has a pink sky. And the reason the sky is pink on Mars is because there is always fine reddish dust in the atmosphere. And the reason that the surface material on Mars is red, that the dust in the atmosphere is red, is because Mars is rusty. Now, while we're here on Mars, I think it's important to do a British custom. It's a program might not be shown at this time, but this time is certainly tea time. And I wonder if we could have some tea on Mars. Thank you very much. So I will pour tea, and as I do, I'd like to talk a little bit about what's the next thing to do to study Mars. Because, you see, here we are stuck in one particular place on Mars, and it would be nice to go to other places. To do that, we would have to have a spacecraft which could move about on Mars, which could rove. Would you like some milk in there, or would you have to take a bite? Some milk, yes. And so we have to have a spacecraft with wheels, with tractor treads, which could land in the safe and dull places, like here. It's not so dull because, after all, we're having tea, but it is dull compared to almost everywhere else on Mars. Would you like some more? Let's see. And so that is a technology that we have. We could land space vehicles that look something like this, but have wheels on them, and go off to the exciting, terribly nice places, the enormous volcanoes, the river valleys, the places which are different from the Earth, which are exciting. We can try to look for life in the places which are different from Chryse and Utopia. We have not yet done that. We may be able to do that soon. Our technology is capable of it, and who knows what further mysteries are to be found on Mars.